Thanks, guys. Welcome to the session on malware protection for Amazon S3. Um, quick introductions. My name is Akshat. I'm a product manager on the S3 team. Before joining S3, I used to work in Amazon last mile operations. So if you see the blue vans that come deliver your packages, I manage one of those buildings. You'll hear from me today. You'll also hear from Scott and Sujay. I'll let them do their introductions when they're up on stage. So our agenda for today, we're going to start with a quick primer on Amazon S3 and how we think about baseline security. We then look at solving for untrusted uploads, go into enabling and using malware protection, which is the sort of new product that was launched at Inforce. How do you manage identified malware within a particular account and at scale? And then finally look at operationalizing that for multiple accounts within your organization. To get us started, architecture matters, right? Amazon S3 is built differently. Our four key pillars are durability, security, availability, and performance. We hold more than 350 trillion objects, exabyte scale data, offer 99.99% availability by default, is backed by one of the strongest SLAs in the cloud, and offer best-in-class performance and security. To delve into that a little bit deeper, I'd like to take you through a recap of the shared security model. So AWS is responsible for our sort of infrastructure, the software that we build, keeping it secure. And on the customer side of the responsibility model, we expect you to use the security tooling that's built to keep your data secure, building the right configurations in the cloud. Moving on, to start off, S3 is secure by default. We've taken multiple steps in the last couple of years to change defaults in ways that help you remain secure in the cloud. The first one is encryption by default. So any new data that lands in S3 is encrypted. The other two are at the bucket level. So S3 block public access is turned on by default. S3 access control lists are turned off by default for new buckets that have been created. We made this change in April last year, helping keep customers safe everywhere. I'll hand off to Sujay now to talk a little bit more about malware protection.
Yep. Right. Thanks, Akshat. Hello, everyone. This is Sujay Doshi. I'm a senior product manager with Amazon GuardDuty. I hope you're having fun with last 3 days in Philadelphia and had a great Inforce. So before we dive deep into the details around this new feature that we launched, let's look at some of the use cases for which we see S3 used by customers across the industries. We see S3 used for implementing data lakes. We see customers using S3 to store log data. We see customers using S3 as part of the data pipeline and storing the infrastructure-related data. But we also see customers having applications, content websites that accepts data from external sources. And we don't know whether the sources can be trusted or even the data that's uploaded can be trusted or not. So now moving on to some examples of untrusted application uploads. We'll see it from the perspective of two different scenarios. First, where we have external users uploading untrusted data to S3 buckets. Think about application like chat, like a video conferencing application that has a chat button where customers can upload files. Think about social media applications where any user can basically upload any file per the limits. Think about healthcare application where patients can upload medical records. Or also think about support agent software application where you have customers upload support cases and the relevant files to this. Now, let's look at examples where internal users are uploading data to applications that are backed on S3. Think about an e-commerce website where internal teams are uploading approved images as per the product catalog, Also, we see S3 prevalently used for build management software where you're storing binaries that can then be distributed internally as part of the build pipeline. Why is this a problem? In all these examples that we saw, can we trust the provenance of the data? What happens if the data that's uploaded indeed turns out to be malware? Do we understand the risks to the organization if the data is then downloaded or either accessed by users or applications? So we are happy to introduce GuardDuty malware protection for S3, where now using GuardDuty, you can protect your S3 buckets from new objects that are uploaded that turn out to be malware. GuardDuty will continuously monitor new objects that are uploaded to the configured S3 bucket. It will detect it for malware. It will apply tags, generate event notifications, and will also generate findings that can then be leveraged for you to implement downstream remediation and data isolation workflows. It is a fully managed offering where the list of malware signatures, they are continuously updated, and it's powered by GuardDuty's managed threat intelligence system. Most importantly, there is seamless setup with minimal configuration that your application and security teams need to do so that your application team can focus on building the application logic, all while securing the scenarios where untrusted data is uploaded to the application. So what are the key benefits? We get quick enablement, wherein with just few clicks, either using the console or using CloudFormation template or using API, you can basically secure the pipelines that are built on S3 that involves applications with untrusted uploads. Since we use regularly and continuously updated list of malware signatures, the finding that gets generated will have contextual information related to the S3 bucket metadata, S3 object, the scan related information, and we'll also have the malware category that will help your incident response teams to take workflows such as isolating it to quarantine buckets. It's highly scalable, where GuardDuty with this feature will not only detect, but also set you up for implementing protection controls in form of object tagging that allows you to then use bucket policies so that you can prevent access to objects that are deemed as malicious. But most importantly, this relieves you from the complexity of managing the compute infrastructure, where your application teams, neither your application nor your security teams, kind of need to manage, operate, and incur the additional cost of the associated compute required for malware scanning. So let's imagine a world where cats are building applications. And there is a request that they have a new application that needs to be launched. Also, let's imagine in that same world, we have dogs who have the duty to guard your enterprise. So their response is that let's review the architecture and define the purpose of what will be the role of the bucket, collection bucket. So the application team responds that they need to store customer uploads. Well, that's untrusted, as we all identified, and in that world, even dogs think so. And that's untrusted data, and it needs to be scanned before we need to process. So the next question is obviously, what is the recommendation? So this is the use case that with this feature we are trying to solve, where we enable your application teams to implement mitigating controls that are identified as part of your threat model reviews with the security team. More importantly, security teams can set the standards which your application, different application teams building different applications and requirements that interfaces with untrusted uploads can now use the recommended and approved malware scanning solution so that you don't have to go through cycles of, let's say, license renewals. You don't have to go to managing the infrastructure, so on and so forth. There is a baseline that can be established for all applications that includes untrusted uploads. So let's take an example where we have an application. There's an upload button, and external users are uploading data, which is then stored in user documents bucket. As soon as you configure GuardDuty, it will automatically monitor, will scan, apply tags, generate findings, will have metrics. And then you can use that data, that information, to then kickstart your downstream workflows, such as implementing a Lambda function to isolate it to a quarantine bucket. More importantly, you can implement tag-based access control, wherein using bucket policy, you define that do not allow access to any objects in a bucket as long as it has tag clean. What this will do is, even when scan is in progress, the system does not allow access to the objects till they are vetted by GuardDuty. All right, so let's talk about really how a typical scan works. We have workloads deployed in US West 2 region in a customer account. There's a bucket, awesome app uploads. We have GuardDuty configured in the same account. When you configure malware protection for S3 on this bucket in the region, there is an event bridge rule that's created in your account, which is basically going to be monitoring for new object that gets uploaded. So we'll be monitoring put object events. What this does is, it will basically be a trigger to the malware scan service in the same region, where we will then download the data, run the scan, delete the data, tag the object, and that's the information that gets written. But more importantly, if you have GuardDuty, the core GuardDuty that's enabled in the service, the security administrator, in even the same account, you'd see a GuardDuty finding with all the contextual information. We'll get to see on what all information that's there. But this also, using Event Bridge, will generate scan-related status. Not only that, it will have information related to the health of the protected buckets. In case of an delegated administrator, they'll be able to see this information across all member accounts and all the buckets belonging to them. So now, a very important thing that we want to discuss is what are the guardrails we are taking to implement the data, the customer data that we are downloading, even though in the same region, but in a separate service account. And just like everything we build in Amazon, AWS, security is a day zero function. So we have different layers where we have implemented guardrails. So in terms of network isolation, the scanner Lambda that we are using is isolated and there's no internet access. It's part of a VPC that's attached to a DNS firewall group that will only allow requests to allow listed AWS domains. This is to prevent, think about DNS exfiltration type attacks. The communication with S3, additionally, happens via private link. So it's completely isolated. There's no way from internet anyone can access the scanner compute. In terms of the data level protection, when we download the S3 object into the scanner service account, it gets downloaded to the ephemeral storage. At rest, the data is encrypted with AWS Lambda managed KMS keys. The object, every time once the scan completes, it's deleted. And in order to verify, even for the components that we trust, every time a new scan begins, before that we check that the storage space is empty. The storage is not shared between different instances, which is between different scans. In terms of the operator access controls, we download this to Lambda service managed instances. So all the similar operator access control measures that apply to be trusting AWS Lambda applies to this service as well. Importantly, there is contingent authorization that's required for access to Lambda and GuardDuty service accounts. And GuardDuty operator roles explicitly deny assuming IAM roles that are not in the service account. Now, what are the prerequisites to use this feature? Yeah, apologies for the dramatics, but this indeed is actually the only prerequisite. What do I mean by this is, this feature can be used by any AWS account that has a S3 bucket belonging to synchronous storage class. And that's the only prerequisite. What do we mean by this? If you see on your left-hand side now, when you get started with GuardDuty, you get an option whether you want to use the core GuardDuty and all of its different protection plans, things like runtime monitoring, Lambda protection, audit log monitoring, and even this feature, but the prerequisite there is that you need to have the base GuardDuty enabled, or you have some account wherein there's really no activity, no workload, but there's only a requirement where you have an application that's accepting untrusted uploads. So you can just use this feature by itself, because as we saw in the diagram, we generate event notification via event bridge that you can consume. Tags apply irrespective of whether the core GuardDuty is enabled or not. And that's kind of a flexibility that we'll provide. But once, whichever mode you decide, as part of the configuration on the console, you just need to provide the bucket information. You can actually also scope it down to the fact that only monitor for objects that are uploaded to a prefix and not the entire bucket. So that's a configuration that you can have. We recommend tagging, but for whatever reason, as part of the operating procedures, you cannot use tags. You can choose that option. And then provide the role, which will have the permissions to establish that trust relationship for all the things that GuardDuty service principal will do on your behalf. Once we have this set up in that account, you'd have the list of protected buckets as part of the summary and the health status for that. With GuardDuty finding, as you can see, there's contextual information that's related to the bucket metadata, the malware category, the object level information, and then if you go to S3 console, you'd see a tag that's added with the malware scan status, which you can then use to kick off downstream workflows. Let's look at what's the usage and how that translates to what an end user is estimated to pay. So the pricing goes with $21.215 per 1,000 put requests. And this is all available on the pricing portal, but then it's 60 cents per GB. And then there is free tier for every account. There'll be free usage of 1,000 puts and 1 GB free every month for the next 12 months. And look at some examples, right? Varied sets, like the first one's a mom and a pop shop, a small one wherein there is 6,000 files that are uploaded every month, with collectively that is 20 GB, which is somewhere monthly spend for that will be close to $12.50. And same way for a big enterprise that has like close to 600,000 files uploaded, which ultimately turns out to be 200 gigs, it's close to $248. So now I'll hand it over to my colleague Scott, who will walk us through on how this can be operationalized in your environment. Cool.
Thanks, Sujay. Thanks, Sujay. Good afternoon, everybody. Quick intro. Scott Ward. I am a principal solutions architect. I work on our security services product team. I work with customers to help them understand how our services work, help dive deeper into how they can actually implement our services in their environment. And then I also partner with our product managers and engineering teams to identify what else do we need to build, what are the next things that customers need, and partner with them to make sure that what we build is actually going to be useful to customers when it's actually delivered to them. So Sujay highlighted, how does the malware scanning work? How do you enable it? I want to talk more about what do you do after we've actually identified that there's malware in your objects in your S3 bucket. What are some of the approaches you can take, and how can you best operationalize this? And so I've broken it down into 3 categories, focused on notification, being able to control access, and then being able to actually contain the malware. Some of the use cases I present may work for you, or you may have another flavor of that, but this is at least to get you started in thinking about what you might do with this feature. So to start with, let's focus on the notify aspect. So we have in this example, GuardDuty is enabled, or not enabled, but GuardDuty is still performing that scanning function on the S3 bucket at the end of the day. As Sujay highlighted before, if you have GuardDuty enabled, every time malware is identified, it will create a finding in GuardDuty. GuardDuty sends a copy of every one of its findings to Amazon EventBridge, and you can write a rule in there that matches those findings and send that on to a target. The target can be one of over 20 plus AWS services that you can then use to orchestrate sending that off to a ticketing system, Slack, email, whatever works for you, from like a notification or a heads up that a malicious file's been uploaded and exists in your S3 bucket. We also send that scan status event to EventBridge, and that'll happen either if you have GuardDuty enabled or if you're just using the standalone S3. That will have information about every object that was scanned and insight if it was clean or infected. You can also write rules against those and then send that off to any one of the 20 plus targets to orchestrate sending that event off. So in both cases, whether you have GuardDuty enabled or not, you can catch events that indicate that you do have malware and be able to match those and send them on for the appropriate notification and the appropriate orchestration. Controlling access. So we talked about object tagging earlier. There's a little bit more information here on how that object tagging actually looks. So if you have enabled the object tagging, we will tag every object that GuardDuty looks at, even if it is clean. So every object would have a key of GuardDuty malware scan status, and then the value is going to vary. We're going to have the no threats found, meaning it's clean, we don't see anything there. Threats found, meaning that we've identified malware and there's a potential threat to your organization. Unsupported, meaning that we can't scan that, and more than likely unsupported means that it's too big. And we'll talk about the limits here in a minute. Access denied, meaning we got the notification that there's an S3 object, but we can't actually consume it. GuardDuty can't read it. And then failed, meaning there was some sort of an unexpected event happened on the processing side in the GuardDuty platform, and we couldn't scan it. So every one of your objects will end up with one of these tags if you enable the tagging feature. So what are some of the things you can do with that? Well, one of the things you can do is actually implement an IAM policy or a bucket policy that actually limits which tags you can interact with. So in this example, this is actually an example bucket policy, and it's authored that a specific role can only get objects if they're tagged with the no threats found attribute. So any new object that comes in is not going to be tagged at all. And then once we scan it, we will tag it with the appropriate information. And so this is going to limit and ensure that whatever this role, when it is retrieving objects from S3, it can only pull in the clean objects and continue that on into the processing pipeline. So this is an S3 bucket example. You could also craft something like this as an IAM policy and attach it to the role directly to influence that. And you could certainly reference other tags in this process as well. But this is an example of how you might control access or ensure that only clean files are actually leaving that bucket. And then there's containing. So there are things that you can do in order to isolate that malware or make sure that it is not part of your standard happy path pipeline for any objects that you're receiving into your S3 buckets. So in this example, we have our bucket, we have GuardDuty configured to be able to do the malware scanning. We have our end users, whether it be internal or external, that are sending data to this bucket. GuardDuty is getting that object and doing its scan. We're sending out that information, whether it be a finding or the scan status, to EventBridge. And in this example, we're actually setting a target of a Lambda function. And the Lambda function here its purpose is to evaluate the message and make a decision on what to do next. And what could you do next once you've identified that you have that malware? So one, you could move that infected object to a quarantine bucket. Get it out of there, put it somewhere, maybe even put some additional permissions around that bucket to really limit about who can even get that bucket, maybe just a security team, maybe just a research team. This would work both for the finding or for the scan status, because they're both going to send you information that, hey, there's been malware identified. You could move the clean object to a processing bucket. I've talked with some customers that they actually have like a second staging bucket that's actually where the application connects and gets its information, and it can't connect to the actual original bucket. In this case, in order to make that work, you would actually be relying on the scan status result, because only the scan status is going to give you information about the non-infected objects. And so you would have something, an EventBridge rule, looking at the scan status, see that this object has come through as clean. You could then move it to the bucket where it can be sourced from. You could delete the infected object. You could just say, okay, well, we know that that's malware. We're not going to allow it on. We're not going to do anything else with it. What's the point of putting it in a isolation bucket? We're just going to delete it. Or you could remove it from the downstream pipeline. So some customers, when they receive those objects, the pipeline that they process them is very time sensitive. They need to get these things through. They need to process it. They can't hold anything up. What they'd rather do is that we'll just notify them when when the malware's been identified, and they'll, based on the attributes of that object, go retrieve it and isolate it or pull it out of their further downstream processing. And that means that nothing's blocked and everything can continue on its happy path until we tell them otherwise. And so these are a few ways that approaches you could take to contain that malware and make sure that it doesn't introduce itself further to your employees or end users or to your applications downstream. So a key thing to keep in mind is what does this look like and how does this approach function when you are operating in a multi-account environment? So the top account represents a delegated admin account. So GuardDuty is enabled in there and it can see all the other member accounts. For the delegated admin account, it will get a finding not only for anything that's happened in a delegated admin account, but it'll also receive a copy of all the findings for all the member accounts that are part of the organization that delegated admin account is for. So you would see all the S3 malware findings would actually show up in that top level delegated admin account, and they would all get sent to Amazon EventBridge. The top level delegated admin account also gets what I call setup notice. Sujay mentioned this earlier. Anytime somebody has configured malware protection on an S3 bucket in any account in the organization that the delegated admin account can see, it will receive a notice that malware scanning has been set up or modified across that entire organization. So as a centralized security team, you could use those notices to alert yourself on any events. Maybe somebody deleted a scanning configuration. You want to go investigate that further and make sure that that's actually the way it should be, or use it to confirm that a team has set things up correctly based on a particular threat model that you've discussed with them and a mitigating control that they need to have in place. Now for the member accounts, the findings are just the findings. Anytime GuardDuty identifies malware, if you have GuardDuty enabled, it will create a finding, it will send it to EventBridge. But if you're going to rely on the scan status, so that previous example where we talked about where maybe you're going to move the clean files off to their own bucket, that scan status happens only at the member account level. So if you were going to take that Lambda function approach of evaluate every message and I'm going to move that object around, you would actually need to deploy that Lambda function into every account where you have S3 malware scanning configured. So in this example, if I'm running 2 different accounts that are going to have different buckets that I'm monitoring, that Lambda function to evaluate the messages from each one needs to be in each account. So keep in mind of that as you're kind of looking to operationalize or set up any monitoring that you're looking to do around these buckets. If you were to implement something at the top level account, which you would only be able to do really for malware found objects, if you did a Lambda function at that top level account, keep in mind that it will need to have access to all the other buckets in all your member accounts in order to be able to do any work that you might want it to have it perform. Okay, some additional things to keep in mind. When you turn on this feature, whether you're turning on full GuardDuty or you're using just the S3 malware scanning portion, we will create a new CloudWatch Logs log group for you in your account and give you different metrics that will help you better understand what's happening with malware scanning. So we will give you metrics on failed scan counts, so that's that failed tag I talked about earlier. Skipped scan counts, which would be those access denied or unsupported. Completed scan counts, which could be infected or uninfected, and then infected scan count. So you could use these metrics in a couple of different ways. So you could use the failed or the skipped scan counts. You could put a threshold on those and actually have a notification go out that you've hit a threshold and you might need to go investigate further and see what's happening with those particular objects or with that particular bucket if you have a certain threshold. The completed scan count, just to kind of understand what is our state or how much scanning is happening on a daily basis. And then the infected scan count could also be used to help you understand across a larger time series how much infected data are we actually receiving from these untrusted sources, as well as you could use it as a threshold once again, that maybe you want to do a deeper dive into what's going on if you hit a certain amount of objects being infected in a certain day or across a certain time series. That would make your security team want to investigate further that maybe you have some other event happening that's causing this. So those metrics are there for you to use and kind of keep better status on what's going on across your GuardDuty and your S3 malware configuration. So additional thing I want to highlight here and how to operationalize this is that, once you have, we go back to that conversation earlier with the application team and the security team. So we get to the point at the end of that conversation where the security team has finally decided, we're going to use GuardDuty. We're going to standardize on GuardDuty as our approach for scanning newly uploaded objects to S3. They've made that decision. So the next step for them is that they're going to want to grant the application teams the ability to actually configure malware scanning for their S3 buckets. So there's a couple of GuardDuty actions. You would create an IAM policy that grants them those specific actions so that they can perform that configuration. And then the application team is going to embed into their deployment process, setting that scanning up as part of their infrastructure as code templates. So right now at launch, we have CloudFormation support. This is an example of the CloudFormation resource definition. It's very straightforward, just like the screenshot you saw. You're going to say the IAM role that has permissions to be able to, GuardDuty can use to go and get the data out of the bucket name, any prefixes, and if you want tagging enabled. So now what you've done as a security team is you've set the standard. You've said, here's what tool you need to use. Now, security team, the application team, you need to implement it as part of your standard processes and make sure that you're configuring this as part of your initial deployment. So it's a way for your security teams and your application teams to reach consensus and allow each team to be able to do their job and deploy the configurations that are necessary. So what does this not do? Just want to kind of make sure that everybody is aware of, when we talk about this feature, what can you and can't you do? Currently, it is not a historical scanning solution. You can't take this feature, say, take this bucket that I've been collecting data in for 3 years and scan it all to see if I have any malware in there. It's not built for that. It's built for new uploads coming in as part of an application or some sort of a file transfer. It's not a malware detonation service. You can't upload malware to it and we'll detonate it and tell you everything about it that we know and what are all the domains it's communicating with and which threat actor do we think this is from. It's not that feature. If you upload malware to it, we're going to scan it and say it's infected with malware and that's it. It's also not a malware prevention feature at this point. We don't orchestrate all those things to actually prevent the malware from entering your environment, or we don't scan it as it's put into the object. We scan it into the bucket. We scan it after it's been put into the bucket. So it's not a prevention feature. And it's also not currently a malware response solution. So we tell you that there's malware there, we tag it, we give you all the information that we have about the malware that's present, but the response to that is still you as a customer. So some of the items I talked about earlier could be leveraged in order to be able to facilitate that response. You also can't, the limit on scanning objects is 5 gigabytes. Anything over that 5 gigabytes is going to result in that unsupported tag that I talked about earlier on. And then we also cannot support objects that are encrypted with the customer provided keys. So this is when you actually, as you upload an object, you provide the key that you manage and we encrypt it at server-side encryption. We don't, because you've provided the key, we can't decrypt the object when we try to retrieve it. So those are some of the limits, as well as some of the things that this does not do. So just to recap for everybody on what we've talked about today. So first, just untrusted uploads and scanning those for malware. That's an important item. It's an important thing to keep in mind, and it's an important thing to look at as you're looking at the existing applications you have and as you're designing new applications. GuardDuty malware protection for S3 is squarely built to be able to help and support that untrusted upload scenario. You have a lot of flexibility in how you manage that identified malware. There's things you can do, notification, the tagging, the containing approach. And then it's important for you to look at a strategy of incorporating that configuration of the malware scanning as part of your application definition and deployment. Allow your application teams to actually include this as part of their configuration and identify it as a best practice. Okay, so I'd like to, first of all, thank everybody for coming out and spending your time with us today. It's been a pleasure to do this and to partner with Sujay and Akshat on building this content. Please make sure you fill out the survey in your mobile app. We'd love to hear your feedback. Tell us what you wanted to hear more about next time. We look at that feedback and we look to improve ourselves based on that. We're all going to hang out down here. If you have any questions, come on down and we'll be happy to talk more about this with you. So thank you, everybody.